Here we go. Now we're going to talk still about a transversal, but now the two lines that it's going through are going to be parallel. And so if you look at this picture, we have lines L, M, and T. Remember yesterday, L and M kind of were tilted a little bit differently, so they would have hit each other as well. And so then in that picture, any of them could have been the transversal. But here it's very easy to see that really only one of those three lines has a chance of being a transversal here. Because remember, that means it has to hit two or more lines, and the only one that's going to do that in this picture is T. Okay. So the postulate, again, that's something that we kind of assume to be true, is that if two parallel lines are cut by a transversal, has that happened in this picture? Well, right now we don't know, because I don't believe that I have any markings in there that show that those two lines are parallel. There it is. Now do we have two parallel lines cut by a transversal? Yeah, now we do. Again, don't assume things. Just because they look like it doesn't mean that. All right? So we know those are parallel because of the markings. Remember, if you have multiple parallel lines, you just start making more arrows. All right, that's all you got to do. Then it says each pair of corresponding angles is congruent. Well, corresponding, that means you have to remember what that means from yesterday. And what's the one word missing from corresponding angles is there's no interior, no exterior, and that's the easiest way to remember that one. Neither one of those words is in there, so it's got to be one of each, right? So a good example would be, say, perhaps, angle 6 and angle 2, right? Because top right, corresponding spots. Those are corresponding angles. But also remember, corresponding is the one that actually has 4 pairs, where the rest only have 2 pairs. All right. So here it says if the measure of angle 4 is 70. So let's put that in there. All right, because you have that information there, right? Yep. Okay. What is the measure of angle 8? And what is the measure of angle 7? Well, can we get 8? Is that corresponding with 4? And if these lines are parallel, based on this postulate, can you tell me 8? You better. It says they are congruent, which again means same shape, which obviously they are, right? They're angles, all right? And same measure. Okay, so it's 70. All right, so angle 8 is 70 degrees. Well, can you tell me 7 then? Is that something we can actually do? Yes? Exactly, because 7 and 8 go together to form a, what are those called again? They are supplements, but linear pair, there we go. And so it is 110. Okay. So that wasn't overly difficult, was it? Pretty straightforward. What's the key? You need to know the lines are parallel before you can do that. Next one. If two parallel lines are cut by a transversal, do we have that yet in my picture? No, we don't. Okay. Now do we? Yeah, now we do. Then each pair of alternate interior angles is congruent. So wait a minute. Corresponding are congruent. Alternate interior are congruent. So then the measure of angle 3 here, it says it's 100. Then determine measure of angle 8 and 7 again. Well, if that's 100, which one's alternate interior with that? Angle 6. So angle 6 must be 100. Well, then why are they asking me about 7 and 8 over here? This postulate doesn't help me get that. But now I can get it, right? Yeah. Very good. 6 and 7 are vertical. You see what I mean? How you have to remember all those things from before? So angle 7 is also 100. Very good. And then 8 is actually a linear pair with 7 or with 6, correct? So it's got to be 80. Because you see how you could go that way or the other way? Doesn't matter. All right? So make sure you read that one. All right, here we go. Two parallel lines cut by transversal, then each pair of consecutive interior. Uh-oh, this is different. is supplementary. So, because so far the two have been congruent, right? It's been corresponding are congruent and alternate interior are congruent. Here it's saying supplementary. What's that mean again, supplementary? We just talked about it. Has to add to 180, yep. So, okay. Well, once again, I really can't do this one yet. Why not? Yeah, we don't know they're parallel. And plus, do we even have a question on this one? Not really, but we can talk about it quick. But again, we don't have even parallel. Maybe I don't even have it on this one. Nope. Now I do. Well, there, let's make it even different. There. All right, so now we know they're parallel. Now consecutive interior. So interior obviously have to be 3, 4, 5, or 6, right? So which one? 3 and shut up. 5. So what if I told you, say, this was, I don't know, that looks kind of smaller. Let's say that was, let's make it interesting, 75 degrees. If that was 75 degrees, then what does angle 5 need to be? I just shout it out. 105? Because supplementary means. So wait a minute. Let's just kind of look at this for a second. Well, if that's 105 right there, what's angle 7 got to be? And doesn't this hold true with the very first one that we did? Those are corresponding. Didn't they end up the same? Okay, so it's not like they were lying to you. And then angle 6 has got to be what? Well, for a lot of reasons, right? 6 and 7 are vertical, but also didn't we learn that these two were also supposed to be congruent? Didn't we learn that already? So then guess what this one over here has to be for a lot of reasons? It's got to be 105. Is this the only reason that it's alternate interior? No, because it's also a linear pair here, right? And it's also consecutive interior there. So you see how they all work together. It's not as if they're all different. They're all working together to get these numbers so that they all match up. Okay? Now I know you don't necessarily have a picture for that one, but you could draw one off to the side or whatever it is you need to do. And well, we've talked about corresponding, alternate interior and consecutive interior, leaving us with alternate exterior. I don't know if I have them on here either. Nope, well, I'm slacking. There you go. Alternate exterior are, well, we're back to congruent. So really there's only one oddball, right? And that's this one. Consecutive interior are supplementary. All the other ones are congruent. All right, so for exterior, we better get the ones on the outside. And so 3, 4, 5, and 6 are on the inside, so 1, 2, 7, and 8 are on the outside. And watch out, I won't always number them this way, so be careful. So alternate exterior would be 2 and, say it, shout it out, 7. All right, so if I told you, again, maybe this one's, let's change it up here, 60 degrees. Then by default, this one down here has to be 60 degrees. And then angle 6 has to be 60 degrees. By alternate interior, this one has to be 60 degrees, right? And does that match with vertical with 2? It does. And then if you do linear pair for 4, you get 120, right? Vertical to 1 gets you 120. Alternate interior to 5 gets you 120. You could do corresponding to 8 gets you 120, which matches with vertical. You see how it all works together? They are not fighting each other. If you follow all of them, you should get the same numbers every time. Okay, it should work out all the way through. All right? Any questions on that so far? Okay, so they all work together. But anyway, I guess probably the easiest way is remember consecutive interiors is supplementary and the rest are congruent. But again, here's where things can get interesting when you start getting multiple lines. Okay? It can make things a little bit more complicated. Okay, determine the values of x, y, and z that will make C parallel to D. So is it telling me they are? No, but it wants me to make it so that they'd have to be. And all you have to do is make all those things come true. And M and L parallel. All right, I think we can do that. Well, the reason I like this, one of these is sticking out to me because I've been given 4 places where they talk about the angle. One of them sticks out. Which one seems to stick out? Yeah. 98. Why does that stick out? Because it's a number, right? Let's face it, we prefer numbers over algebra anyways, right? And so what I would do is, why don't you get started? Again, I basically want this to end up parallel to that, and that to end up parallel to that, correct? So let's kind of just, here, let's do this for a second. Whoops. Only look at what you need. Okay? So can we work with that? Well, what's got to go where I just put that red dot? Because they are congruent or vertical. Do we know what has to go where I just put the red dot now? What has to go there? 82. Yep. So down here in the red dot, it's also 82. What goes where 14Z is? What can I put there if I want? A 98, right? Because these two angles where I see 98 right here and there are alternate interior. And you see how L is the transversal of what you can see right now? I kind of put the box over that other stuff so you can't even look at it. That's kind of like you putting your hand over the stuff you don't want to see if you're looking at your textbook. All right? And so in other words, I put 14Z and 98 in the same location, right? Which means if they can both be in the same location, they better be equal. Or there's at least a Z value that will make them equal. And so that's when you go to your algebra to figure out what value that is. And you go ahead. Is there any guarantee that these variables are going to be nice numbers? No. Does this one work out okay, though? Yeah, it's not terrible, right? And I always do that with Z's so you don't think it's a 2. I do the same thing with S's so you don't think it's a 5, right? And so Z is, well, what is that? 7? So Z is 7. All right, we're off to a good start. And why don't we just keep going here? This would be 98, right? This one here is, you see how I just kind of fill it in, and then I try and answer the question? All right, there we go. So that's pretty good. So I filled that all in, but there's more variables, right? Okay. And so what you might want to do is let's take a look at what we've got here. Now let's do this then. Well, that's interesting. All right. Do we now have a different transversal than we had just a second ago? Yeah, with the lines you can see now, what's the transversal? C. So do all those things still hold true? I want these lines to be parallel, right? It still holds true. Because we knew a 98 was right here, right? So what's got to go over there? 98. All right, so then 98's got to go here. And 82 was there, so what's got to go over there? Well, 82. And let's face it, 82's got to go there as well, doesn't it? And so once again, we see two things that are occupying the same location. And that is a 2x plus 5 and an 82, right? Is it okay if I erase this work over here so I have more room? Everybody's got that down? There we go. And so 2x plus 5 and 82 have occupied the same location, so we can solve that. Again, dividing by 2 is an option, probably not a very good one, though. So let's subtract 5. 2x equals 70-something. Oh, 77. I was like, 70-something. Well, of course it's 70-something. All right, divide by 2. Is that okay that x is so much bigger than z? Yeah, because you have to find the x value that's going to make that angle be what it needs to be. It doesn't matter its relationship to z at this point. And does 38.5 make that angle end up being 82 like it's supposed to? Well, if you put it back in there, it does, doesn't it? Okay? And so that's really all you should be concerned with at that point. Okay? So now what you should do, so now again, basically this is my hand down here, this box. I'm covering it up. So at this point, there's stuff I can't see, right? I've covered it up with my hand. So we got to kind of move where you kind of cover things up. And so then you're going to go like this. Maybe do something like that, right? So now you kind of just keep on going. And so that right there, it has to be 82. Or you could actually do it this way, because what's 98 and 3y plus 8? What kind of angles are those in this setup? Corresponding. All right, so 98 can go down there, right? We got that. So 82's got to go here. 98's got to go there. And all these angles kind of have to go there for more than one reason. Okay, and so that's really good. But once again, we have algebra and a number occupying the same place. I'm going about 50-50 on this whole erasing thing today. All right. So 3y plus 8 and 98 occupying, oh, this looks like this is going to work out fairly well. All right, subtract 8. 3y is 90, very good. Divide by 3. Y is 30. Again, is it okay that y and x are kind of close to each other as numbers go, and then z's just not even close? Z was 7. Yeah, that's fine. All right. But the whole idea is that when you substitute all those variables back in, do you get the angle you're supposed to? And I believe we do. Okay. So again, you might want to use that idea of using, your hand or something to cover up, or a sheet of paper to cover up what it is that you don't need in that picture at the current time. Because let's face it, I start getting rid of this, and that looks way more complicated than it did a second ago. You might not have thought so. You're like, oh, it's not that bad. But look at that. There's stuff everywhere. Okay, but if you kind of cover up as you go, it's a little easier. Okay? But of course, there's a slight difference in this problem. How is this? Obviously, there's fewer lines in this one, right? So that should make it easier, don't you think? But why is it so much different? Yeah, there's no, I didn't give you just a number. So are we going to have to possibly work a little harder? Possibly. But let's look at our options. Okay, our options are that I could take these two angles right here and add them together to be 180. Do you agree with that? Because they're a linear pair. That's an option, right? So we could do that. So that's option red, we're going to call it. We've got option green. Those two angles are what type of angles? Just the special angle pair name is what I'm looking for. Consecutive interior, very good. And consecutive interior is kind of that oddball, remember? So those have to be supplementary, which means those two, the green option, would have to add together to be 180. Agreed? And then there is a blue option that these two have to be congruent because they're alternate interior, correct? So three options, red, green, and blue. I believe one of the three is easier than, you could actually do it any of the ways, but there's one way that's way easier than the rest. Yes? Why is green easier? It's the same variable. Do you agree the other ones, red and blue, both have x and y in them? Okay, so green's by far the best option. And so wait a minute, so what did we say about green? We said that the two angles, were they equal or did they have to add to something? Yeah, they had to add to something. And what did they have to add to? 180. Okay, so that's probably the best way to go. These two are on the same side, so go ahead and add them together. Minus 10. I wrote it down right? It's minus 10? Yep. Yeah, I think dividing by 19 here is a really, really bad idea. So let's add 10. We'll save that dividing for a little bit later. Ooh, seeing it comes out way better than expected, right? It doesn't have to be this nice, but it worked out fairly good. Divide by 19. Y is, 10. Again, does it have to be a nice number? No. Doesn't have to be. It could be some kind of decimal or really not nice fraction. Okay. So here's the problem, though. We go back here. We did the green option. But still, if I go back and do blue or red, I still have two variables. So how do we proceed from here then? Yeah. Exactly. Pick one of the two options and put 10 in for y, right? And does it matter red or blue at this point? No. Which one did you say? Red? Let's do red then. All right? So that means we got to take this y and put it in there. But really, all these angles are working together. So did it really matter red or blue? It didn't. All right? So we got to go 6 times y. Okay, if y is 10, can everybody see that that would be 60 sitting right here? Is everybody okay with that? Okay, so in other words, 60 is one of our angles, and 9x plus 12 is the other angle, correct? And how is it that we knew the red was a possibility? Yeah. Okay, very good. And red was an option from the beginning because they were a linear pair, right? And so we had to know, add them together to be 180. So 9x is still sitting there. These two can actually just be put right together. Actually, dividing by 9 is not a horrible idea on this one, but you got to divide everything. So we're going to work down here then. 9x, cancel, equals 108. Divide by 9. Now you can give your answer. Once again, are we guaranteed that these two answers are necessarily going to be that close to each other? No. None at all. Okay? And if you wanted to, obviously you could put all those back in and make sure the angles end up what they're supposed to be, but that's completely up to you. Okay? Some people probably would have attacked that problem a little bit differently. They would have said that 9x plus 12 has to equal 120. Is that an okay way of finishing that problem? Yeah, because if this one over here has to be 60, right? Doesn't that one have to be 120? And didn't we get a number in algebra in the same location? Yeah, so that's kind of what we did in the first one. Okay, so what some people do is once they get one of the numbers, they kind of do it the first one that we did. Okay. This ends up being pretty important. It seems pretty obvious, but it says if you're in a plane and if a line is perpendicular to one of the two parallel lines, then it's got to be perpendicular to the other. I think that should be relatively straightforward, right? If I shoot that one right through there and it's perpendicular to the one on top, doesn't it kind of have to be perpendicular to the one on the bottom? If they are, there it is, parallel. Wow, that's working really well. There you go. If they're not parallel, are you guaranteed that if they're not parallel? No. But if they're parallel, it's perpendicular to one. Now wait, does that follow all the rules? Because this has to be 90, right? And then that's 90, and then that's got to be 90, and so does that, and so does that, and so does that, and so does that. So these are supposed to be congruent, right? These are supposed to add to 180. Do they? Yeah. These are supposed to be congruent. Yeah, so all those rules we learned today still hold true. It's just a very special case, okay, where they're all the same. Okay? Any questions?